Hi, this is we are presenting the online retail data analysis and clustering as part of the AI-501 project. And this project is worked on by Antan Tyagi and Vinay Mittal, and both are associated with the team AI-5. The aim of this exercise, the project is to identify closely associated customers in a data set of online transactions. And based on the analysis, we build a RFM framework, which is our baseline framework. And then we use clustering algorithms to improve our baseline and make our solution more data-driven solution. A brief about the dataset. The dataset contains all transactions occurring between 1st December 2010 to 9 December 2011 for a UK-based registered non-store online dataset. And the dataset can be leveraged for customer grouping and clustering access that we are presenting. It can also be leveraged for product recommendations, building relevant recommendations for different kind of customers based on their past purchases. And then marketing framework and strategies, which can be designed to target relevant customer, increasing the overall retention, overall performance of the marketing campaigns. The primary objective of the exercise is to facilitate the development of a customer-centric strategies by integrating customer relationship with analytics. The idea is we built a baseline model, which is a business-driven model, and then try to improve on that by using clustering, which business can use to gain deeper insights into the analysis. In the current competitive landscape, it's very imperative that businesses tend to understand their customer. It helps businesses to improve their relationship with their customers, improve the user experience, and it helps overall improve the standing of the product of the standing of the product with the customer. Customer customer segmentation plays a very important role in that. And customer segmentation can be defined as the act of dividing a homogeneous customer base into segment, which reflects similarity among each other group. And the advantage of building this segment is you can tailor their products, tailor recommendation, services, and marketing effort to meet the need and preferences for the target audience. We are building a customer segmentation framework, starting with the baseline and traditional recency frequency monitoring metrics, and then based on unsupervised ML models, not starting from k-means, hierarchical clustering, and the DB scan. So the business objective is to enhance customer target strategies. Could the idea of customer segmentation comes into like to improve the business targeting strategies, identifying different kind of customers' behavior, and then clustering algorithm to define the problem. And we basically try to answer the three questions by three parameters: recency, frequency, and monetary values for the customer. Now we move to a data understanding, a little bit about the data. The data, as I mentioned, it's an online retail data set for an entire year, and it contains approximately 541,000 transactions. And the type of data which are there is the description, which is the description of the product, the quantity purchase, invoice date, which is the date of transaction, and the unit price of the transaction, and customer ID, and the country from which it is purchased. The characteristics of the data is some multivariate data with sequential time series data. It has a lot of missing values in the data, and a lot of we do see a lot of missing details in the data. And now we move forward to a little data understanding, the exploratory data analysis, and the EDA part of. In the data cleaning, what we do is we first filter for null IDs, their customer IDs which are null. So starting from 541,000, we are then left with 406,000 purchases. Then they are like duplicate rows in the data, which we clean and all of those. Then we filter out the negative values in quantity and price, which can be attributed to data quality issues, and they need to be treated and cleaned. And then we arrive at the data for the modeling. To model this, we start with the RFM segmentation, which we start with as a baseline for the model. I'll give you a brief logic of how we are doing the RFM segmentation. So based on like business expertise, we divide our RFM into eight different categories. The first is hibernating. Based on the frequency and recency matrix, we divide into hibernating, at risk, can't lose them, loyal customers, champion, need attention, about to slip, promising new customer, and potential loyalist. And then basically we provide different recommendation based on those RFM scores. So these are the 8 segments that we will create for our customers, and recency frequency monitoring framework kind of tries to identify which customers are relevant for different kind of a campaigns there. Now I will hand it over to the teammate Vinay, who will give a walkthrough and understanding of the algorithms that we are trying to use to improve upon all of these the RFM metrics and models that we have created.
Thanks, Antan, for introducing us the problem statement and walking us through the data and the insights, also proposing the solutions. Now let me introduce the machine learning models which we'll be using in our solution and deep dive each of them with the pros and cons. So the first up is the k-means clustering. So k-mean clustering at its core is it partitions the data into k clusters by minimizing the sum of squared distance between data points and their assigned cluster centers. It iteratively adjusts cluster centers and reassign points until it converges. Talking about the advantages of the k-means cluster, it is quite efficient for large transactional data where clusters like high spending and low spending customers may be roughly spherical. So yeah, it's mostly working well with the spherical clusters. Also, um, it it guarantees to converge in a finite number of iterations. These are some of the advantages of the k-means clustering. Talking about the disadvantages, it it I believe cannot handle outliers very effectively, which can be common in transactional data. For example, in our use case, there are some of the few exceptionally high spending customers, and also this is sensitive to initial centroid placement, potentially leading to suboptimal clustering. So yeah, these are some of the limitations of the k-means clustering. Next is hierarchical clustering. The hierarchical clustering builds tree-like structures called as dendrogram by iteratively merging or splitting clusters. It doesn't require a predefined number of clusters. So it produces a dendrogram that shows the tree-based structure and allows for different levels of depth and selections while assigning the clusters. Now, talking about some of the advantages, it provides an interpretable dendrogram to visualize customer segmentation, which can be insightful for strategic decisions. It can handle non-globular cluster shapes better than K-means. Talking about some of the disadvantages, I believe this struggles with computational efficiency, especially for a dataset with many transactions and customers. Second is it is very memory intensive as it needs to store and process a primary metrics, proximity metrics, and it is also sensitive to noise and outliers. So these are some of the cons of hierarchical clustering. Next, we have DB scan. So DB scan is one of the clustering algorithm which identifies dense region in data by grouping points that are close together and marking outliers as noise. It relies on two parameters, epsilon, which is neighborhood radius, and minimum points. Talking about some of the advantages of DB scan, it I believe effectively identifies niche customer segments and ignores noise such as infrequent or anomalous transaction. It is robust to noise at least and does not require specifying the number of clusters beforehand, unlike K-means. Talking about the disadvantages of DB-scan, it struggles with varying densities and it is computational intensive for large dataset with a time complexity of big O number n log n. So yeah, these are some of the limitations of DB-scan. Next, we have Gaussian mixture modeling. So the Gaussian mixture models assumes the data is a mixture of several Gaussian distribution. It uses the expectations maximization algorithm to estimate the parameters iteratively, and it assigns soft probabilities of cluster membership, allowing points to belong to multiple clusters with different probabilities. So yeah, this is how the Gaussian mixture modeling works. Talking about some of the advantages, it can model complex non-spherical cluster shapes by using different covariance matrices. The soft clustering allows probability of cluster membership. It also models elliptical clusters very effectively. In our case, it models customer behavior probabilistically, allowing for the nuanced segments like customers who fit into multiple categories like retail, wholesale, buyers, etc. So yeah, these are some of the pros or advantages of GMM. Talking about the cons, so firstly, it requires the number of clusters upper hand, and it is computationally more complex compared to k-means and can overfit with small data set or when too many components are used. So yeah, these are some of the disadvantages of Gaussian mixture models. Next is spectral clustering. So spectral clustering uses graph theory. It forms a similarity graph from the data, computes its Laplacian matrix and clusters based on the eigenvectors of this matrix. This captures the structure of a nonlinear data. So this is how a spectral clustering works. It kind of performs clustering in the low dimensionality space, typically using k-means or another clustering algorithms. Talking about some of the advantages of spectral clustering, it effective for non-convex clusters and can capture complex cluster shapes. And it can leverage global relationships. So yeah, these are some of the advantages of spectral clustering. Talking about the disadvantages, it is computationally expensive, especially for the large datasets, which limits its scalability for year-long transactional data. It requires careful tuning of similarity parameters, and it is less interpretable compared to other clustering methods. This is how the spectral clustering works. Next, we have HDB scan, which is hierarchical DB scan. Now, hierarchical DB scan enhances DB scan by combining density-based clustering with a hierarchical structure. It kind of eliminates the need of an explicit epsilon parameter, finding the clusters by varying density. So it allows for the soft cluster assignment and robust handling of varying density clusters. It then builds a minimum spanning tree of mutual reachability distances and then extract clusters from this tree. So yeah, this is how it works. Talking about some of the advantages, it can handle clusters of varying densities more effectively than DB-scan. It automatically determines the number of clusters, and it handles varying transaction densities and automatically find the optimal cluster without needing to predefine parameters like epsilon. So yeah, these are some of the advantages of HDB scan. Talking about some of the disadvantages, it is more computationally complex than the standard DB scan. It is sensitive to other hyperparameters and may struggle with very high dimensional data. So yeah, these are some of the limitations of HDB scan. Now we have explained and deep dive into each of the clustering algorithm. Each has its unique strength and limitations. Next is evaluation of these algorithms. While evaluating of these algorithms, we have found couple of scores. One of them is Silout score and the other one is Fogg-Mello score. The Silout score is basically how similar each point in a cluster is to its own cluster, which is cohesion, compared to other cluster separation. So this is how it evaluates, and it values ranges from -1 to 1, where 1 plus 1 refers to a perfect clustering, which is the point is closer to its own cluster rather than to the other clusters. Where 0 is more or less a point which lies on the cluster boundary, and -1 is a point which is closer to the another cluster than its own. Good about this, high average silout score, which is closer to +1, indicates a well separated and compact clusters, whereas a low score closer to negative or 0 suggests an overlapping cluster to improper cluster assignments. Next is Focus-Mello score. This score measures the similarity between the predicted clustering and ground truth labels if available, and it evaluates the balance of true positives versus false positive and false negatives. Unlike So unlike siloed score, its value do not ranges between -1 to 1, but from 0 to 1, where 1 is the perfect match between predicted and true clustering, and 0 is a no match. What's good about this score? So a high FM scores indicate good alignment with the ground truth or business defined clustering, whereas a low FM score suggests misaligned clusters, possibly indicating a poor choice of algorithms or parameters. So yeah, this is how the both scores needs to be interpreted. In nutshell, Silhouette score ensures that clusters are compact and well structured, which helps validate the segmentation, reflects distinct customer behavior patterns, whereas FM score checks the alignment of these clusters with business defined categories, providing a quantitative measures of relevance and business utility. So we also assess how well these custom clusters align with the business objectives, such as identifying high value customers. Additionally, we compare these models to the traditional recency, frequency, and monetary models to understand the depth and practicality of insights each approach offers. So yeah, this is how we have gone through each of these algorithms. We have optimized them using the grid search CV and then evaluated on some of the key metrics which I just explained. Now the final part results will be explained by my teammate Anthan. Thank you.
Thank you, Vinay, for giving a great explanation of the algorithm that we are using into this. Then we move to the result. Then we move to the results of the analysis. Now we have all created the RFM framework. We have done all the modeling. Then now we try to compare the results, how our RFM works, and then how do we use the clustering to improve upon the RFM segment. So RFM output based on the business logic and understanding, we divide, as mentioned before, we divide the output into 8 categories, which is hibernating at risk, can't lose, about to sleep, need attention, loyal customers, promising, new customers, potential loyalists, and champions. If we look at the distribution of the users, we can see that based on the RFM segments, a lot of our customers are potential loyalists, followed by at risk, then loyal customers, and then as we go down, we have a very few set of champions, which kind of like is the which should be the end goal for the business. If most of the segment should lie either potential loyalists or loyal customers or champions. So these for to then move forward for these customers, we can then definitely build different marketing campaigns, which we would be discussing some of them down the line. This, if we look at now the distribution of the pie chart, it stays the same fact like 20% of our potential loyalists. These are like customers who transact with us, but we do not call them as like our customer loyal customer base. So this is like highly imperative. These 20% customers should move to the next level, which is a loyal customer. And then we design different marketing campaign, different strategies to convert these customers our our required data set. So, and we then look at the RFM metrics for different customers. If you look at champions, if you look at loyal customers, and if you look at potential loyalists, we do see a lot of recent transactions for them. And we also see a good enough frequency for them. So yeah, and so these are like the 3 categories that we have in our system, but rest of the others we need to have a look at the basically which are the at-risk customers, which we can't lose, which we are hibernating, about to sleep. We need to design different strategies for different kind of customers, which we are going to discuss below. So these are like the 5 strategies that we come up for the RFM, and then we further refine the strategies that clustering. So if you look at about to sleep, we have like 337 customers with the recency of 246 days and frequency of 20 days, and the monetary values to 90. It's a little bit on the lower side, which we see that these customers are not looking to transact in a lot of forward scenario moving forward. So some recommendation which we can do for them is we can offer like a specific promotion of targeting. We do see like these kind of customers are trying to are maybe churning or going off from the product. So we can give a specific promotion or targeting campaign so that they can stay on the platform and maybe offer some different kind of deals and promotion to keep them transacting with us. Then we look at the segment which is at risk, which is very critical segment. It also have a relatively decent size from the customer base. The recommendation that we can tell them is we should proactively reach out to those kind of users, and based on the historical data, we can recommend similar product or win back campaigns so that we can bring out the association of our product with the customers. If we look at new customers, we then see a lot of new customers also on the platform. The new customers, they are like 254 customers with a 40-day recency. And so these are relatively new of our platform. So we can offer them incentive discount or maybe like offer them free deliveries, any sort of offering to convert them into loyal customers on the platform. Also, they might need a little bit introduction for our platform. They might not know all of the features, so give them a communication shout out to tell them about the different features of the platform, which they can, so they have a chance to convert to potential loyalist customers. Then we look at the potential loyalists, which is like a very important base for us, and this is the base which we should further target to improve into the loyal and champion customer. Then hibernating customer is a customer who is very near to drop off from the platform. So we can design focus group to understand the pain points and then work on reacquiring them. So this is the basic of an RFM framework, which we try to improve upon clustering. The clustering which we might want to do is reduce the managing all of these 8 customer segment might be a difficult task. So we might want to bring them to a little bit on the lower side, see what are the relevant customers. If we see that, so right now this is a business logical driven case. If we see, we can build a data driven case based on the clustering algorithm, which tells us which is actually based on the data, what kind of segments we have on the platform. So now we see both of our solutions in action. The baseline solution, which is an RFM solution, which is a logical based solution, and then the clustering solution is a data driven solution. While the RFM solution makes sense if we do not have a lot of data to work on, it is also creates 8 segments, which is really doesn't really capture the interaction between different kind of customers. And so yeah, it's a little bit basic. And then to improve, so we can use clustering as a parameter to improve upon those. If you look at this now, when we have arrived at, we looked at k-means, we arrived at 4 clusters. We can like now narrow down our recommendations from 8 to 4. So it kind of helps us to simplify our marketing schemes. It kind of helps us to then bring together the data that we have on the system, build effective data-driven strategy, and then we create different cohorts based on clustering algorithm, which narrows down our RFM from 8 to 4, which we can then simplify our targeting for different kind of segments and different kind of user bases. This concludes our project, and yeah, Vinay and I have worked together as a part of the AI 501 module. Thank you so much.